So we made it to the next group of learning objectives. We're now in the kind of not require stuff, but things that the more you do, the more you kind of understand the stuff that's only going to benefit you in terms of the exam in your future math classes. If you look at the numbering, we're back to 1.04. So that second number there kind of tells you what these are all related to. So we're actually going back to the first thing that you had to do in this unit, which was inverse trig. All right, so remember we had these things that look like sine inverse and cosine inverse, also arc sine. These two things mean the same thing, arc cosine. So we'll see things like this again. We're just going to be using them in a slightly different context, doing kind of one extra step over what you had to do in the required learning objectives. All right, so the first thing is, what is a composition of functions? A composition of functions is when you put one function inside of another. So the way it looks, we might have these two different functions, f and g. And we're basically going to put this g function inside of the f function. And what does this mean? Well, we take some x value, right? Order of operations, we kind of start on the inside. We take that x value and plug it into g, and that's going to give us some answer. Maybe g takes 2 and sends it to 3. All right, so now I'm going to get some answer. Whatever that answer is, I take and put into f. All right, so it's kind of this double-step process of functions. Right? So an example of this might be, your input might be the hours you work. When you know the hours you work, you know the amount of money you get paid. When you know the amount of money you get paid, you can figure out the amount of tax you're going to have to pay. So there's kind of a two-step process of figuring out how much tax you're going to make based on the number of hours that you worked. All right, so this composition of functions just helps us kind of do several functions at once. And there's nothing stopping you with 2. You could do more. I don't know what next letter to use. And just keep kind of looping things together. Once you know tax, you can figure out something else. Once you know that, you can figure out something else. All right, so for now, we're just going to worry about 2 things. All right, but composition of functions just means you're putting one function inside of another. And we've actually done this before, but maybe didn't call it this when we did things like this. All right, we put the inverse function inside of the original, and they kind of cancel out, and you get back to x. And we also did it the other way, too. All right, so it is something we've done before, but maybe just didn't call it this. But now we're going to be looking at it specifically with inverse trig functions. All right, so in this example, we want to calculate the value of this expression. And again, with the composition of functions, just like our order of operation, we want to start on the inside and plug that in. All right, we know our sine inverse functions, our inverse trig functions are going to give us some angle. And then we're going to take that angle and plug it into cosine. All right, so let's just focus on this inside part first. All right, if sine inverse of 4/5 is going to equal to this angle, that means that our original sine function of this angle equals 4/5. So it's kind of rewriting this expression using our inverse property where you flip those two things. And this here is something that we've seen a lot of. Sine of theta equals 4/5. What I can do is I can make a right triangle. I pick my angle theta as long as it's not the right angle. And sine is opposite over hypotenuse. So opposite is 4, hypotenuse is 5. All right, so this angle theta here represents the answer for that inside part of our parentheses. And now we want to figure out cosine of that same angle. Well, cosine is the adjacent side over the hypotenuse. So now to finish this problem, we just need to figure out the adjacent side using the Pythagorean theorem. And this is a triplet that's come up a lot. So I'm doing it so quickly. Take the square root, you get 3. All right, so the missing side was 3. And the cosine of this angle is going to be 3/5. So altogether, our final answer for this is just 3/5. Because we go backwards from 4/5 to talk about this angle. And then we do cosine of that angle is adjacent over hypotenuse. All right, so it's kind of actually the same question as we worded before. Questions were worded like this: find cosine of theta if sine of theta equals 4/5. All right, these questions basically require the exact same amount of work. All right, just when I write it like this, it's more convenient to just write it as one expression. And I just have to know this first step that I can rewrite it like that. Use my right triangles in SOHCAHTOA to my advantage. So it's really something we've already done before, just written in a different way. All right, so with that in mind, I go ahead and try this on your own. Cosine of sine inverse of 3/5. And here's the solution I came up with. So the first thing, this in parentheses, represents that, all right, that's gonna be equal to some angle. So we have the sine of that angle has to be 3/5. That helps me label two sides of my right triangle. Pythagorean theorem, again, is gonna find that third side. And then cosine adjacent over hypotenuse is 4/5. All right, so our next example, if you compare this to the previous two examples, we've flipped where the inverse is. So in the last two examples, we had sine inverse in here, but now we don't. The sine inverse is on the outside and cosine's on the inside. All right, so this is going to require kind of more, or less SOHCAHTOA stuff and more unit circle stuff. Because for the inside part, cosine of 5π/6, that's just using the unit circle. It's in quadrant 2, and it's related to π/6. That tells me that inside part of this problem is going to be equal to, let's see, cosine of π/6 is the square root of 3/2, so it's going to be negative square root of 3/2. And then the problem that's left over is exactly the type of problem that was in 1.02, that learning objective. What is sine inverse of negative square root of 3/2? And we know that sine inverse of the positive square root of 3/2, we can just use our unit circle for that. Sine inverse of the positive square root of 3/2 is π/3, which means the answer for the negative value is negative π/3. Right, so that's our final answer. All right, so when this inverse function on the outside, it's more of a unit circle problem. When it's on the inside, it's more of a SOHCAHTOA problem. So as you're doing the practice, just kind of make sure you know which one you're doing and what your main tool is going to be. All right, here's your one to try on your own. All right, just be careful when you're doing this one, because on the outside we have cosine inverse. And remember, cosine inverse and sine inverse behave a little bit differently. But go ahead and try this one on your own. And here's the solution I came up with. So sine of π/3, we just use our kind of picture of the unit circle. We know that y value is the square root of 3/2. So we've replaced that in our parentheses. And we do cosine inverse of the square root of 3/2. So we're asking ourselves, when is the x value the square root of 3/2? And that happens at π/6. All right, so just putting those together, we get π/6 is the final answer for this problem. All right, and lastly, the multiple choice question. What is the exact value of this expression? So just as a hint, the inverse trig function is on the outside. So think about what you should be doing and kind of what you should be looking at for this example.